Welcome back to THS Chemistry videos. Today we're looking at calculating heat. We're learning a new formula. So make sure you're following along on the sheet that's provided for you, and let's get going. Okay, so first of all, you gotta know what heat is. All right, so let's get this down. Heat is the transfer of energy. Okay, heat always flows. The flow of energy is from a high temperature to a low temperature. Heat always flows from the hot to the cold. Okay, they ask questions on this a lot. Heat always flows from hot to cold. Okay, when heat is added to a substance, it can either raise the temperature or it can change the phase of the material, like a phase change, like solid to liquid, liquid to gas. Okay, if you're losing heat, you would go from a gas to a liquid or a liquid to a solid, or you could lower the temperature. Okay, so heat can be added or lost from a substance. But either way, it's a transfer of energy. Okay, you got to understand the difference between heat and temperature. Temperature is the measure of average kinetic energy in a substance. Okay, that's always a question on the Regents. You'll see it again over and over. Temperature is average kinetic energy. Got to know that. It is based on a scale. So Fahrenheit, Celsius, Kelvin. We measure temperature in degrees Celsius in the classroom. You're going to use the thermometer in Celsius. We don't use Fahrenheit. All right, you can convert to Kelvin. Okay, so temperature is based on the scale. We can measure temperature using a thermometer. Now, heat is the transfer of thermal energy between two materials that are different temperatures. Okay, so it's always going from hot to cold. If they're the same temperature, there would be no overall heat transfer. So there would be no heat gained or lost. Okay, so you got to have temperature differences to have heat and transfer. Okay, so the unit of heat is called joules. All right, make sure you get that one down. All right, it's also sometimes called calories. It's a different system, but the SI, the metric system, we use joules. Okay, food calories. Okay, that's measuring energy in calories. Okay, all right, let's keep moving here. Okay, calculating heat. We can use the following formula for any solid or liquid that gains or loses heat, not gases. Calculating heat is not the same as measuring temperature since they are different. Okay, we can't just measure heat by temperature of a thermometer. Okay, so the temperature of the thermometer will help us measure heat, but it's not going to be the measurement of heat. Okay, so our formula here is going to be Q equals M times C times delta T. Delta means change. Okay. This formula is on the back of your reference table. It's a very back page, table T. Look it up, know where it is, know how to use it. Okay, so Q. Q stands for our heat. All right. M is for mass. C stands for specific heat of a substance. I'm going to get into that in a second. Okay, you probably don't know what that is. Now, delta T is change of temperature. You got to know that delta T is always T final minus T initial. All right, every time. That way, yes, you can get a negative. A negative means you're losing heat. Positive means you're gaining heat. All right, we'll get into that in a second. Let's talk about specific heat here. Okay, now you don't have to write this down. Pay attention for a second here. Specific heat is C. All right, that's our value. Now, what specific heat is, by definition, is specific heat is the amount of heat it takes to raise 1 gram of a substance, any substance, by 1 degree Celsius. So it's how much heat am I going to raise this 1 gram by 1 degree? Right? The unit is joules per gram times C. So each substance has its own specific heat value. Okay, these are known values that we've given to you. You don't have to magically know these. Every substance has its own value. All right. Water's specific heat value is on table B in the reference table. Go look it up. It's on the reference table. It's on the front page. Look it up. You're going to have to use it. The value is 4.18 joules per gram K on the table, or the same thing as 4.18 joules per gram degrees Celsius. It's the same thing because units of Kelvin and Celsius increase and decrease by the same unit, one unit. Fahrenheit's different. Right? We don't use Fahrenheit science, well, at least in the metric system. Okay, so that means it takes 4.18 joules to raise the temperature of 1 gram of water by 1 degree. All right, that's specific heat. Okay. Now, if you notice, if you ever look up specific heat values or ever used them before, metals have much lower specific heat values than water because iron 0.44, zinc, copper. Okay, these are so much lower because heat can absorb metals can absorb heat much faster than water can. Okay, they heat up faster. The reason why is because they have smaller specific heat values. Okay, that's why they specific heat. Iron, metals, they heat faster than water does. All right, let's keep moving here. All right, solving the equation. This is what you got to learn today. Just got to make sure you know. Q equals mc delta T. Let's look at a practice problem. So flip on the back of your sheet. All right, you got room for your practice problem here. You're going to set it up and follow along with me. Okay, so write down Q equals mc delta T. All right, here's the problem. How much heat is gained by 100 grams of water if the temperature of the water was raised from 10 degrees Celsius to 40 degrees Celsius? Okay. Anytime you get a problem, you got to know what is the question asking. This question is asking how much heat is gained. Okay, so heat is my variable I'm trying to solve. So that's Q. All right, grams is mass, so I have 100 grams. That's my mass. My specific heat for water, well, you're going to go look at it up in table B if you haven't done it yet. And I just talked about it, so it's 4.18 joules per gram C. Now, delta T, remember that's change of temperature. It's always T final minus T initial. So T final here is 40 because that's where I stopped. T initial is where I started. I started at 10 degrees. So 40 minus 10 is 30. Okay, be careful of this. All right, students love to put in 40 for my delta T or 10 for my delta T. You got to do the math. Okay, it's always T final minus T initial. So set the equation up on your paper. Q equals, Q is my variable, 100 grams times 4.18 times 30. Okay, do it in your calculator. All right, pause this for a second if you need to. All right, so you should get a value of 12,540 joules. All right, and if you know your sig figs already, you notice that there's 3 sig figs is my least amount, and since I'm multiplying, I used the one with the least amount, so there's 3, so it's 12,500 joules. Okay. A lot of variables. Don't get tripped up, okay? This one's, let's take a look at a practice problem here. Okay, you're going to do this one on your own. Now your practice is how much heat is gained by a 350 gram sample of water that was heated from 50 degrees Celsius to 76 degrees Celsius. So, you use Q equals mc delta T. Okay, what's the question asking? How much heat? So that's your variable. Q is your variable. 350 grams, that's my mass. Look up your specific heat on table B. It's the same thing we've been using, 4.18. And what's your delta T? Okay, solve for delta T, plug it in, multiply them together, solve for Q. All right, you're going to show your work on the practice problem spot on your sheet. Okay, we'll do some more of these problems. We'll get some practice in. Have a good day.